So we're just going to talk about sine on this video, just the sine relationship. We've already done tangent, so this one should be fairly simple. So sine is just another example of a relationship between the sides of a right triangle and the angles. So first we need to specify an angle. And then for sine, you can see by this over here, O over H is opposite over hypotenuse. So sine of an angle equals the opposite side over the hypotenuse. All right, so then we have to go to our angle and we need to look opposite. So opposite is over through end. I like to put an O there. And the hypotenuse is always the hypotenuse. It is the one across from the right angle. So this is what the relationship looks like, without specific information. Now let's use this to solve a few equations. So here's our angle. So we're going to do sine of 72 degrees equals opposite over hypotenuse. So we're going to look opposite the 72 degree angle, and there's x, and the hypotenuse is 9. So we need to solve this just like we solved tangent ones. Multiply both sides by the denominator. So we have 9 times sine 72 equals x. And then you just plug that into your calculator, making sure it's in degree mode. 9 sine 72. Oops. 9. What am I doing? 9 sine 72. 8.6. So the side labeled x is approximately 8.6 units long. Okay. Now the next one, here's our angle. We're going to look for the opposite side. So we have sine of 13 equals opposite, which was 20, over the hypotenuse, which is x. Again, we need to solve for x, so we're going to multiply by the denominator to get this out of fraction form. And then to get x alone, we need to divide by sine. So x equals, and then you just type into your calculator, 20 divided by sine 13. So that hypotenuse is 88.9 units long, approximately. All right, one more example, this time trying to find an angle. Now I gave all three sides in this just to show you that you can choose in this one which trig function you want to use, but since we're doing examples of sine on this page, I'm going to do sine theta equals opposite 14 over the hypotenuse 15. The 11 doesn't matter in this one at all because it's not part of the sine ratio. Remember, when you're looking for the angle, you need to do the inverse sine of the ratio. And then you just put that in. Second sine 14 over 15. 68.96 degrees. That's all there is to it. Happy doing sine stuff.